Introduction to Hurdle Technology, Part 2. In this presentation, we shall talk about dimensions of hurdle technology. We will be more focused on some medical aspects related to hurdle technology on food products, barriers of food, hurdle technology and enzymes, hurdle technology for sustainable food processing, and the quantitative approach of hurdle technology. So we will discuss for the potential of wider use of hurdles and some relation of hurdle technology with other concepts. Let's talk about dimensions of hurdle technology. Hurdle technology is not a new way of food processing, but this is a combination of factors and methods which consist in increasing the storage time or shelf life of food products. This combination was done based on preservation of food general methods like heating, drying, salting, acidifying, fermenting, etc. After the principles behind these measures became known, example how to quantify heating by F values, how to quantify drying by water activity, how to use acidifying by pH and treatable acidity. Preservation treatments could be quantitatively expressed in values of temperature, water activity, pH, etc. Initially, the concept of hurdle technology was only used to improve the microbial stability and safety of foods. The next step was to include also sensory and nutritional quality in the optimization of foods by hurdle technology. Recently, new dimensions for application of hurdle technology are under discussions. These new dimensions comprise some medical aspects, some barriers to food, hurdle technology and enzymes, hurdle technology for sustainable food processing, a quantity approach to hurdle technology. Medical aspects related to food safety are the barriers in the human body which determine whether foods containing pathogens and might cause or will lead to food poisoning. The natural barriers to the entry of microorganisms into the human body are related with antimicrobial defense mechanisms. In this context, the first line of defense is the saliva. High acidity in the stomach is a very strong hurdle for the passage of pathogenic bacteria. The next lines of defense are the high pH, pancreatic enzymes, and the surface activity of the bile salts in the small intestine. Furthermore, the normal bowel flora in the large intestine plays an extremely important protective role. Gut motility and diarrhea help to get rid of offending pathogens. There are three links of a chain determine whether food poisoning occurs or could be prevented. First, the scope of hurdle technology is enlarged and encompasses the health of the animals or plants from which the food comes. The second, the hurdles for pathogenic microorganisms is a well-designed food products, and finally the hurdles which are active in the body of the consumer. There are some barriers to food. Clean rooms in food processing plants should avoid or at least minimize the recontamination of heated or decontaminated products during processing and packaging. They consist of several compartments or hygiene zones, and they are janked rooms with different purposes for only personnel authorized. Different major example hygiene hurdles are implemented. The barriers taken in consideration in this case are mechanical, for example, special clothing for the employees including masks, gloves and shoes, some physical hurdle related to air filters and excess pressure in clean rooms, which should be cool and dry, some chemical, cleaning without aerosols and corrosions, bactericidal surfaces, and biological for protective cultures in waste pipes. These measures minimize the transmission of microorganisms to the food products during processing and packaging operations. The relation of hurdle technology and enzymes. A number of food enzymes, which are either indigenous to certain foods of plant or animal origin, or have been synthesized by microorganisms associated with this food, can cause spoilage, for example in pasteurized milk or fruit juices, or sensory improvements in long ribbon bones in hams or by tenderization of carcass meat. The enzymes of microbial origin are often still active when the microorganisms which synthesized them have been inactivated by heat or inhibited by lower water activity. The activity of the enzymes in food is definitely influenced by several environmental factors or hurdles. The combination of different factors, for example temperature, pH and water activity, influences the enzyme activity to a greater degree than a single factor. Decrease in temperature, pH and water activity results in a decrease of protease activity, but among them the temperature factor was most effective. In general, a decrease in temperature, pH or water activity is associated with loss of enzyme activity. Stimulation, inhibition or inactivation of enzymes in food based on the additive or synergistic effect of combined hurdles. The impact of hurdle technology for sustainable food processing. Food preservation based on hurdle technology meets consumer demand for safe, nutritious, tasty and convenient food. Gentle of resources since it requires little energy during processing and storage, and low capital investment. So, this is applicable in industrialized as well as in the developing countries. These requirements for food processing methods are in compliance with issues of sustainability and for securing an adequate food supply. Gentle and sustainable food processing based on hurdle technology devise simple guidelines for the preservation of food, which are macrobiologically stable and safe, tasty and nutritious. Easy to prepare by small and medium-sized enterprises and should be storable without refrigeration. Quantitative approach to hurdle technology. The advanced and intelligent hurdle technology, as applied, today is still principally a qualitative approach. Which hurdles are employed for a particular product depends on the type of food, the desired stability and quality, and facilities available. The types of hurdles chosen for a particular food product have traditionally depended on the experience and good judgment as well as trial and error. The chosen intensities of the applied hurdles are often not based on a mathematical statistical engineering approach, but on a compromise agreed among food designers. The established hurdles are appropriate from the microbiological point of view That is confirmed by microbial challenge tests, where the established hurdles are suitable from the sensory and technological point of view, may be judged from evaluation of the quality of numerous experimental products made. A proposed user guide for food design is an integrated approach which combines hurdle technology, predictive macrobiology, and hazard analysis critical control points, or in some cases, quantitative good manufacturing practices. There are potential for the wider use of hurdles. The majority of hurdle preserved foods rely predominantly on perhaps 2 or 3 major factors for their stability. The number of hurdles that are potentially available run into hundreds or even thousands, and very few of these have been seriously explored. The potential for the intelligent application of this must be substantial, and this does not mean that the development of new hurdle technologies will inevitably encourage the chemical overloading of foods. Generally, the technology will allow for a reduction of the levels of individual components through the use of lower levels of a wider range of preservative factors. Use of a wider range of factors necessarily imply the use of a greater number of additives. It should be remembered that many hurdles are not perceived or regarded legislatively as chemical additives. Chemical preservatives may be replaceable, for example, sensible control of water activity, pH, acid levels, etc. The wider use of physical factors are mild heat, high temperature, electroporation, pH control. A wider range of the naturally occurring materials that deliver useful level of antimicrobial activity within a more complex combination of hurdles. On the other hand, under artisanal conditions, there is sometimes an indiscriminate use of chemical food additives. Example, addition of sulfites to fruits or nitrate to meat, and such shortcoming should be prevented by intelligent application of hurdle technologies. Some links of hurdle technology with other concepts. Advanced hurdle technology foods are in general less robust than traditional food products, which often are over-processed and thus possess a large margin of safety. Therefore, if such hurdle technology foods are produced, the applied processes must be exactly defined and controlled. For the design of hurdle technology foods, a first-step procedure has been suggested, which comprises hurdle technology, predictive microbiology, and IGCCP, or quantitative good manufacture practice. The engineering, economic, and marketing aspects have to be considered too. Food design nowadays is requested too. In food design, different disciplines must work together. Macrobiologists should suggest which types and intensity of hurdles are needed for the desired microbial safety and stability in a particular food. The technologist should determine which ingredients or processes are proper to establish these hurdles in food by taking account limitations such as legal, technological, sensorial, and nutritional aspects. Advanced hurdle technology foods require a thorough understanding of principles involved as well as more backup of their production and distribution than traditional food. Therefore, the HACCP concept should be applied. The application of HACCP faces practical difficulties in the developing countries where many small producers prevail. If more appropriate, because often safety as well as quality should be controlled, GMP is preferable, but in the form of quantitative GMP guidelines. The definition and control of guidelines must be backed up by objective monitoring of the governing preservative factors, even in small enterprises in developing countries. The most important of these preservative parameters must be defined and should be quantitatively measured. For example, time, temperature, pH, and water activity. These are most important factors. In this respect, further education and introduction of simple and reliable instruments are needed.